Okay, hi everybody. Good afternoon, good morning, depending on which continent you are, and welcome to this NAV Skills webinar. My name is Mark Brummel, and I will be taking care of this webinar, both as a presenter and a moderator. Today we're going to talk about extending Visual Studio Code to check to clean code. It's definitely not the shortest name for a webinar that I ever came up with, but it certainly describes what we're going to do in this hour. This webinar may not take the full hour for two reasons. The most obvious reason is that I was silly enough to schedule a webinar on my daughter's birthday, which I can definitely not recommend doing to any one of you. So very silly of me.
Now, Mark, should I unmute everybody so they can boo and hiss?
Yeah, let's do that. And yeah, let's make my day. Okay, so before I give the floor to myself, some housekeeping rules. New webinars. Currently, if you go to the website navskills/webinars, you'll find that we have not scheduled webinars yet. The reason for that is conference season. Simply too busy traveling to all the events. Last week, Microsoft turned our world a little bit upside down at directions with all the announcements. So I had all the good intentions. We actually have a couple of good sessions and speakers lined up. You can watch the past webinars on the YouTube channel. We are actually getting close to 1,000 subscribers, pretty cool, and getting close to 50,000 views. If you have any questions, type them in the GoToMeetings window. I don't have any time to look at them during the webinar because I'm kind of my own webinar moderator today. But maybe Rick can watch it while he's on the call. And of course, thanks to our sponsor for taking the cost for the subscription of the GoToWebinar. Of course, we're always looking for content and speakers. Today I had a quick phone call with Luc van Vught, my partner in crime for NAV Skills. And we kind of discussed like, okay, how are we going to do the webinars next year? And we kind of came up with the idea of doing 2 webinars per month. And one of the webinars will be more advanced, like cool stuff like GitHub and clean code and Visual Studio Code and web services. But we also want to do one webinar each month where we kind of introduce something that for most of us is like granted normal and we can do it with our eyes closed. But we're getting new and enthusiastic new people in our ecosystem, and we want to have a YouTube channel where people can go and see, okay, this is Seaside 101, this is RDLC 101. So we kind of want to do like a 101 webinar every month where you as a partner can actually send your colleagues if they want to investigate something from scratch. So that's kind of the idea that we're going to do next year. And of course, we'll have some webinars before we're celebrating Christmas under the tree. So the agenda for today, 6 bullet points. First, I'm going to recap a little bit about what I mean with clean code. Then I'll do a quick introduction for Visual Studio Code. I'm kind of expecting that most of you have kind of played around with it. We've done a couple of webinars about it, but I also realized that we have not really given a VS Code 101 webinar yet. Talking to a couple of potential speakers to do that, but I'll just give a quick introduction into what VS Code is and where to find stuff. And then we'll dive into the actual Visual Studio Code extension. We'll look at the marketplace and do a demo. And then I'll explain the architecture of the extension. And at the end of the webinar, I have a call to action to all of you watching the webinar either today live or during watching the recording on YouTube. So recap. Let's quickly start by going to our YouTube channel. This is, if you go to youtube.com/user/BrummelDS, you will find our NAV Skills webinar playlist. It's almost like, wow, we have like 20 webinars now on this playlist. And this webinar is kind of like a follow-up on the clean code webinar that I did a couple of months ago. Very well watched, very good reviews, and this is kind of the follow-up. So I'm going to recap some of the things that we discussed in there. I'm going to relatively quickly go over it, and if you want to have like the more deep dive background, you can go and watch the webinar on YouTube. So basically what we're trying to solve is something that we call technical debt. Most of the Navision partners that I work with have a lot of legacy code, as has Microsoft as well. Most of the successful vertical and horizontal solutions have been around for a while, and the style of programming that we think is kind of like adopted in the NAV ecosystem is changing over time. And basically what we want to do is we want to clean up some of the technical debt that we left behind, where code units, tables, pages, like solutions went a little bit out of control. I think we've all seen code units that have a function called code, and then you have a function called code2, code3, and you have a whole bunch of global variables. And after a while, you just find out that doing maintenance on your solution actually gets to be pretty expensive, right? So that's kind of the problem that we try to solve. Within the Navision ecosystem, we had for a long time this philosophy of, if it's not broken, why fix it? The way that we work with the standard Microsoft code is that we kind of hack our own changes into the Microsoft objects, and upgrading is easiest if nobody makes huge changes to their business logic. So for a long time, it has been like the philosophy that we just let our code grow organically, and we don't actually refactor into more maintainable units. And I think, or I hope, I expect that people who have been in our ecosystem as long as I have, been doing Navision for 20 years, you will find out that after a while it just takes longer and longer and longer to go through these old pieces of code and do bug fixing and maintenance, right? So refactoring is something that has been on the radar of a lot of NAV partners, architects for a while now, and actually even Microsoft has started to look into it in the last couple of years, right? So how do you recognize if something has to be refactored? And for that we have code smells, and code smells are kind of like the important thing today, because what I'm going to show you and what I'm going to ask you to help me with is we're going to create a tool which is called the AL linter. It's an open source project. Everybody can contribute. There's no charge. Everybody can use it, and everybody can make changes to it. And the AL linter is going to recognize code smells in your code, which is a technology that Visual Studio Code provides, right? So code smells is something that you can actually look at the code, and one of the code smells, for example, is cyclomatic complexity, where every if statement, else statement, case statement, for statement, every time you make a decision in your code, you add a number to the complexity. And we have kind of come to an agreement within the community that if the cyclomatic complexity is more than 7 or 8, then the function is too complicated, and we actually advise to start refactoring that function into multiple new functions, right? Number of code lines, this is an old one. This is actually something that we inherited from the time that we had mainframes with 25 by 80 characters in either green or amber. I'm not sure if everyone in the call is old enough to remember that. But this is not my favorite one, but this is something that you can also use to say, okay, if you have a function that has 5,000 lines, I think it's kind of a no-brainer that it doesn't make sense to try to add any code lines into it, right? I think there's one exception to this rule. In Navision, we have this function where you move data from one table to another table. For example, you have a journal, and you populate an entry from the journal, or you have a sales line, and from the sales line you populate the journal. Those traditional constructs that we have in the business logic, those are always more than 30, 40, 50 lines, because that's kind of related to the number of fields that you have in these tables, right? Another one, number of variables. You can actually count the number of record variables that you have, or the number of code unit variables or report variables. And the more of these variables you have, it's an indication that you have complicated business logic. But we have a bigger issue within the NAV community, which is global variables. The reason we have global variables like as a habit in our community is that the old DOS version of Navision only supported global variables. The old DOS version is actually a big contributor of legacy code in NAV. Actually, I get a lot of questions from people, okay, where does this stuff come from, like a function called code? And for this, I got David Singleton to actually do a really, really good webinar on the history of NAV. Somewhere in this list, I think all the way at the end, yeah, there is a webinar where David Singleton actually explains where some of this legacy behavior comes from. And one of the legacy behavior from the DOS version is that we didn't have local variables, and when Navision converted the C side from DOS to C side, they introduced local variables, but it actually took them a long time to start using local variables. And a lot of Navision developers actually kept that habit of using global variables. And a good indication that you have global variables that have to be cleaned up. This is actually a tip that I got from Eric Hogard, our Danish MVP from Canada. If you see that you are using a reset for your variables, it's probably an indication that you are reusing global variables. And if you see a reset in your code, it's actually an indication that, hey, maybe if you split this code up into two functions with local variables, you don't need the reset, and your code will be easier to read and easier to reuse, right? So we have a couple of code smells identified: cyclomatic complexity, large functions, number of variables, global variables, but also commits and Hungarian notation. Hungarian notation is where you actually explain the data type in the variable name. Hungarian notation is something that was pretty common in the 1970s and 1980s. It's kind of like a habit that we had because there were some programming languages that were not strongly typed. And back then you had terminals that had 80 by 25 characters that didn't have multitasking. Nowadays, if you look at VS Code or C-side, if you hover over a variable, if you hover over it, you actually get like this nice window that explains what type of variable it is and stuff like that. But in the old days, you didn't have that. In the old days, you were debugging code. And in the old days, you couldn't like Alt-tab away from the debugger to look at your variables. You had your screen and that was it, right? So Hungarian notation is something that people invented to explain something that you could otherwise not see in the debugger, right? Navision never had that, fortunately, right? So let's quickly look into Visual Studio Code, because that's basically where I designed my AL linter for. Visual Studio Code is a text-based code editor that we're going to use, hopefully, in the future with NAV 2018. After last week at Directions, everything is like, oh my God, is everything still going to be the same? But let's just assume for now that NAV 2018 will be shipped with Visual Studio Code to make extensions. And then the idea is that everything will be text-based, and everything that you program now in C-side, you can start doing in VS Code as well. The cool thing about Visual Studio Code is that it's actually built on some of the latest and greatest architecture combined from both Microsoft and Google. And Visual Studio Code is a complete open platform. And that means that you can actually create your own extensions for Visual Studio Code. Now, this is extremely confusing. I realize that, because what we are actually doing in Visual Studio Code is that with AL, our programming language, we are creating extensions for an AV. But this is actually about creating an extensions for Visual Studio Code that's going to help us write cleaner code, right? For this, I have to give a big shout out to Tobias Venster, because Tobias actually explained me how to create a extension. It's on our YouTube channel here, video number 16. Get started with creating extensions for Visual Studio Code. And here Tobias actually explains how to create an extension for VS Code. I used that to get started with my project. And basically what I wanted to do and what I'm going to show you is a compiler based on top of the Microsoft compiler. One of the really cool things about Visual Studio Code is that while you are working in the editor, you actually get errors. If you create an error, you basically immediately get like a semicolon is expected, the name doesn't exist, and if you click on those errors, you actually get taken to where you created the error. This is something that Microsoft is doing. This is part of the compiler that they created. It's not really a compiler, it's a pre-compiler on top of the compiler that already exists in the service tier. But you can actually add another compiler on top of that. You can create your own compiler. And within the Visual Studio community, this is actually called a linter. A lint is actually something that helps you with checking your code to see if the code is clean, if the code is maintainable, if the code has any flaws that don't directly break the compiler. The code will work, but it's actually going to help you with writing code. And let's see if we get some linters. This is me, but here we have a C++ lint, CSS, SAS lint, Java linter. If you go to the Visual Studio Marketplace, you will find linters for a lot of programming languages. So basically that's what I did. I actually decided to create a linter. You can download and install the linter from the Visual Studio Code Marketplace. You can actually go to marketplace.visualstudio.com and then search for AL lint. Here you can see that you can actually find this linter. Currently we have 92 installations, which is good. This morning we had 87. We have 2 people rating it. That's also nice, because this morning we had only 1. So thanks, Thomas, for doing that. And here you can also read some documentation. I'll get back to that documentation in a minute. You can also install these extensions in Visual Studio Code. If you go to extensions here, you will see that currently I have it installed, but you can actually search for other AL extensions, and you can find, for example, the AL formatter that Rasmus Ahn has created that helps you formatting your code. You can see that we have the CRS AL extension that allows you to create snippets with design patterns. Very cool stuff that those guys are working on. So you can see that other people are creating extensions for AL as well, and this is where you can actually grab it and install it, right? So what the extension is doing, it's actually it's trying to make you help write cleaner code, and to do that, actually check some stuff. The first thing I always do is I'm just religiously against Hungarian notation. That's a personal thing. So that was kind of the first thing I tried to build in is can we actually check if people are using Hungarian notation in variable names and function names. So basically what you see here is you don't see a green or a red line like Microsoft is using, but you actually get a green line, and the green line is more like a warning. It's not really an error message. And this is telling you that this function is using Hungarian notation. And if I remove the Hungarian notation, the green line is gone, and the same is true for the integer. If I remove the explanation, then the Hungarian notation is no longer detected, right? You can see that immediately in the bottom, the errors or the warnings are updated. If I click on a warning, it immediately takes me to the warning in the code. You can define your own Hungarian notation checks. You can enable and disable it if you want. I know that I'm not the only one who doesn't like Hungarian notation, but some people like doing it. So you can actually enable it or disable it if you like that, right? And then we have a couple of other things that we check. I actually got a lot of really good suggestions on LinkedIn. One of them is that if you program a commit, it actually gives you a warning. You know that if you have to put in a commit, then it's actually a good indication that you have to look at your code and see if you can actually have to restructure it. So it gives you a warning on a commit as well. And in this case, it also says a text constant should be declared with a readable name. The reason we have like text 000 and text 001 and text 003 is also something that we inherited from legacy. When Navision moved from version 2.6 to 3.0, we moved from translating the hardcore application to multi-language codebase. And the guy who created the tool that transformed the existing Navision codebase just came up with this idea of numbering the text constants. And it took us as an ecosystem 10 years to figure out that this is not a smart way of doing it, right? We actually had people creating these kinds of text constants. But of course, it's better to say default journal text or question or whatever. Right, everything is better than text 0005. There's a couple of other things that I check. One of the things that I actually like a lot myself. Let me see where I actually put that in. I had a code unit where I actually put this in, but I can actually just create it again. So let's say that we have a function here, a variable here. This is a local variable, example journal template. If we copy and paste this also as a global variable, the AL compiler allows us to have global variables and local variables with the same name. The compiler in Navision was always fine with that. In most versions of Navision, it will prefer the local variable against the global variable, but it can cause you real headaches when debugging scenarios like that. So in this case, it actually gives you a warning that you have a variable which is declared both as a global and a local variable, which is not a good idea. If you have a table object, and let's go into one of the table objects here, we have a setup table, and do we have some code here? Yeah, here we have some code. If you decide to put a with statement in a table object and the page object always have a local scope. It means that the current rec variable is the current scope. And if you start programming inside a table with a with scope, the current scope becomes ambiguous. So actually the linter gives you a warning that a with statement should not be used in a table or in an object, right? Then we have the solution. Okay, what do we do with large pieces of code? So let's go back to our code unit. Let's say that within our code unit we have a more complicated function. This code unit has a couple of functions, and what I can see here is in the left bottom of the screen. I hope you can see it. Currently here we have a green text, and the green text is saying not in function, maintainability index 0, cyclomatic complexity 0. It tells me that because I'm currently not in a function. If I jump into this function example person is visible, it actually tells me that the maintainability index of this function is 64 and the cyclomatic complexity is 2, right? As soon as I start creating another if statement in this function, cyclomatic complexity becomes 3. Maintainability index is an algorithm that I found on the internet. If you go to MSDN, MSDN actually explains maintainability index. It basically means that every function starts with 171 points, and then it goes into a really complicated algorithm based on the number of code lines and the volume of your function. And it basically means that if you go down to 0 or 9, it's a bad function. If you go from 10 to 19, it becomes yellow, and otherwise it's green, right? So currently this one is 63, which is good. And this is hopefully an indication that, okay, if your function is bad, then you should start refactoring something. So this is a function that has a lot of lines of code. So let's say that we want to take these lines of code out, right? If we want to do that right now, we have to we can cut the lines. We can go to the end of the code unit. At the end of the code unit, we can create a new procedure, and we call it foo, and we can actually paste the number of lines in here, and then we call the function from the beginning. This is actually an improvement from the old days, because in the old days in C-side you had to declare the function in metadata, so it's actually easier to refactor in VS Code. But wouldn't it be nice if you can just select these code lines and move them directly into a function? Well, you would be surprised how few lines of TypeScript you actually need to do this, because I can say Ctrl-Shift-P, and here I have a function which is called AL refactor. And if I say AL refactor, it actually creates a function called foo. And if I jump to the definition of this function, it moves the code into my function. This is, of course, work in progress. This is not finished yet. I think it's better than nothing. I have to work on the indentation. Maybe I should give Rasmus a call to see if he can help me with his algorithm for indentation. And of course, I also want to show a pop-up window that will actually show ask you for the procedure name. I mean, of course, in VS Code we can just rename this to something useful, but it's better to just create the correct name right at the beginning. So let me jump a couple of slides, because I actually did a couple of this stuff. I did the demo. Now I want to show you the architecture. And the reason I want to show you the architecture is that I need help. If I go into my let me go to GitHub first. If I go to my GitHub repository, github.com/Mark Brummel, here we have a repository, VS Code AL lint, and this is all the code that you need to create the linter, right? If you clone this, if you download the zip file and you unzip it to your local folder, you have my code. You do with it what you want, create your own linter, create your own stuff. The more tools we get, the merrier, I think. You can also clone it and officially contribute to the project. That would be the nicest way to do it, because then we can actually work together, and then we hopefully end up with 10 or 12 or 15 contributors who are all adding ideas to the linter. If you've never worked on Visual Studio extensions before, I really urge you to start with watching the video that Tobias did, who is going to explain the basic plumbing of a Visual Studio Code extension. I'm not going to dive into that today. Today, I basically want to focus on three things. And the first thing is the README file. The README file actually is the file that you see if you go to the Visual Studio Code Marketplace. The way that the guys who are doing the marketplace did their homework is really fantastic. The guys who are making the marketplace for Dynamics 365 app source can really learn something from this. Because basically what you do is, if I go into my project, if I go into my package.json file, my package.json file is connected to my Git repository. So basically in this file, I'm telling the tool to connect it to my Git repository. And if you connect it to Git in the marketplace, automatically your README file will show up as like the homepage, and it will automatically connect you into the license, changelog, downloading, project details. If I go into Q&A, it will show you the GitHub repository, and if I click on the GitHub repository, it takes me to the GitHub issue list. Right? I'll get back to that in a second. So here we have the README file, and I will actually explain how to set up the linter. And there's a couple of things that you can actually set up. First of all, you can enable or disable the entire linter. So you can just say lint disabled, and maybe someday you are working on a project where the linter is just really annoying because it's old code and you don't want to care about clean code. So you can just disable the lint for a specific project. You can enable or disable the status bar. You can disable the commit. You can disable the Hungarian notation, and you can even add Hungarian notation options to your project if you think that the Hungarian notation options in the default project are not the ones that you want to check for. Right. I want to add more options here. I think you should be able to enable and disable every check that we do. So we'll probably add more options to this file. Right. So the README file is important. The package.json file is important because in the package.json file we add the options for enabling and disabling the checks. Then we have the TypeScript code. And this is where I had to do most of my learning because I was completely unaware of TypeScript. But I actually fell in love with it. TypeScript is a really nice language. It's a nice, I think it's a nice combination of AL, C#, and JavaScript. It's truly object-oriented, allows you to create objects, to write clean code. And if you look at the structure of the project, extension.ts is kind of like the main file. It's like code unit 1 in Navision or main in C#. And this is basically where the extension is activated. If you want to know all the details from this stuff, you have to really watch Tobias's webinar. But this is really where you start the extension. And the way the extension works is I actually created a TypeScript model of the AL programming language. And I discussed this last week with the guys from Microsoft who were in Orlando doing the sessions. And I asked the Microsoft guys, am I doing a smart thing? Am I not reinventing the wheel? And they told me that the debugger or the precompiler is based on the Roslyn compiler. And the Roslyn compiler is designed in such a way that if the Microsoft guys want, the Microsoft guys can actually allow us access to their plumbing. But they currently don't do that. So currently the way that the precompiler is built by Microsoft is that we don't get access to the variables. So what I mean with that is, if we go back to our AL code, is if we had access to the plumbing, we actually had access to how many procedures does a code unit have, how many variables does a code unit have, right? And currently we don't have access to any of that, so we have to do it ourselves. In order to be able to do that, I have created a couple of objects, and the first one is, and the most important one is alobject.ts, and here we have a class, and the class is called alobject, and it has a couple of members. It has an array of fields for a table, an array of variables, and an array of functions. And then we have all kinds of properties that we need for the clean code checking, right? It has a constructor, and the constructor takes the text from the editor. So the constructor is actually called with the entire content of this window. And the entire content of this window is broken up into pieces in order to create the object. So every object in your AL project becomes a TypeScript object, and the TypeScript object has all kinds of methods. And we have functions, and functions have a whole bunch of parameters. Here you can see that we can say we have a function which is Hungarian Notation. It starts at a line number, it ends at a line number, it's a local function, it's a trigger function, this is the health stat volume. So all kinds of stuff that we need for checking. We have variables. Variables can be a parameter by reference, can have a length, an object ID, and all kind of stuff. It's a global blah, 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 what have you. And we have functions, and we have fields. So for every object that you open in VS Code, I'm constructing a TypeScript object. I have a couple of helper functions, like this is for Hungarian Notation. This is actually the refactoring code. You can see that the refactoring code really is only a few lines of code that that is creating the foo function. And then we have the diagnostics. And the diagnostics is a library. The diagnostics is taking an AL object and the current context of your screen, and the diagnostics is creating diagnostics for every line that it finds, right? So it browses through the lines of your code editor, and for each line it checks for a commit, it checks for a width in the page. Then for every AL function it checks for Hungarian Notation, for reserved words. I actually didn't show this. If you go back here and you create a new procedure, let's try to create a procedure set range. Set range is a reserved word, right? So you should not call a function set range or action or something like that, right? So this is going through all the rules, and it's going to check if the rules apply. And if the rules apply, it's going to create a new diagnostic. And the diagnostic is something internal for VS Code that's going to show you that the little green line with, like here we have text commit is poorly structured code, a with statement should be used here. What you can see is that I actually created quite a few lines of TypeScript. Most of these code lines are created during my flight actually to Orlando. And what I would like to end this webinar with is for you guys a call to action. I'm basically requesting two things. First of all, I would like you to test it and use it and see if it works. But more important, I need ideas and maybe even people who are willing to help me. So if you go to the AL-lint repository on GitHub, you can see that currently we have 3 open issues. If we just remove all the issues and we go to the closed ones, where can we find the closed ones? I always have. Currently we have Dimitri actually showing an issue. We have Mike Glue who helped me with some testing. So what do you think we should test, right? This guy can do almost anything. It's pretty cool. So what do you think we should be able to do with AL code? Throw in the ideas, put them on GitHub. TypeScript is a really nice language to write in. I hope Microsoft is going to give us TypeScript extensions instead of JavaScript extensions. It's actually a really nice way of programming. And that's basically what I wanted to show you today. So with that, I'm going to open my GoToWebinar window, and I'm going to go into the questions. And currently we have one question. Bernard, could it also work for CAL? Okay, so this is a really good question. I'm not sure. The way that the linter works is that the linter is coded against a file extension. So Bernard, I would like you to test it. If you export a bunch of Navision objects to a text file and rename it to AL and just open it and see what it's doing, maybe we can make it work. So sure. Any other questions or feedback? Was this worth spending time with you guys instead of my daughter on her birthday?
Absolutely, Mark.
Thank you, Rick. Okay, we are not getting any more questions. So with that, okay, so we have Igor, and the Igor is telling me that he's using it with Cal, and it works to some degree. So Igor, if you want, please, if you find any issues working with Cal, put them on GitHub. If it's easy enough to fix, we'll fix it. We can actually clone the project and maybe change the extension. Simon is saying, great idea, we'll think of ways to contribute. Thanks, Simon. Okay, well, with that, I would like to thank you all for your time and see you in one of our next webinars. Thanks, Rick, for being with me.
And thank you, Mark. Thank you all.
Bye.
Have a good day. Bye-bye.